Sorry about that. Open source software. So yeah, I'm going to concentrate my talk mostly on Gearman. I may pronounce the name like very differently on every single slide, so bear with me every time that I'm trying to say Gearman, Gearman, whatever, you know what I'm talking about. So we're going to get right into it. We're going to understand why the need of job queues based on mistakes that we've all made in the past. And when I'm saying the past, I'm probably talking about like last week. So this is a regular sign-up form, whatever, in Cake. You know, everything looks okay. You know, you're doing just handling the post form and sending an email. You know, pretty much, I think most of you do it this way, but it's a very bad idea because you're actually making the user wait for the email to be sent out, which is insane. If you're doing something that doesn't require user interaction, you shouldn't be making the user wait for that to happen. I wish I knew the background of this photo because it's awesome. Bad ideas. Could be email sending, like we were just seeing. Could be notifications, throwing some sort of notification from your application as part of the user interaction. Messaging to multiple users, like if you have a board and handling the post of a board, you know, a user posts a message on a board and you have to create an unread or whatever notification for the different users. You do it on the same as part of the user request. Imports, oh yeah, imports. We pretty much everyone probably experienced applications where you need to import something and you do the import processing on the request. Even that's insane, so yeah, please don't do it. Counter cache, this is pretty much all over the place. Actually, if you use counter cache behavior in Cake, you're doing it wrong because you shouldn't be doing any sort of counting or whatever in the operation where the user is requesting. Because the number one rule of Fight Club is you should not make the user wait. Stop making them wait. The solution is something that is weird, which is apply communism to the internet. Communism on the internet is a pretty good idea. So we should start getting into that. You should start thinking about spanning workers all across. Everything that can be done without the user interaction should be done, you know, without the user interaction. So pretty much the idea behind applying communism to the way you work, you know, you program is outsource everything that you can outsource. And I keep saying that in different presentations. So how should we try to actually make our code more communist and less, you know, less not communist? You should be thinking about something that dispatches an action. Like in the action that we were seeing, controller, I don't know why I put that picture, I'm sorry. I was actually, I think of controllers as secretaries for some reason, because they control stuff. When I was looking for a sexy secretary picture, the first picture that showed up on Google was Justin Bieber. So if someone knows why, just please explain it. So yeah, something that should say, okay, we need to send an email. So instead of sending the email, create some sort of something, message, whatever, for something else, a worker to process and send out the email. That's the way that every single job queue works. So the ingredients to create a job queue, a simple job queue, could be a channel for dispatching tasks, some way of communication that you can have between 2 points, 2 servers, 2 whatevers, so you can talk to each other and understand, which is in our previous slide was a simple JSON message. So what's the other ingredient? A job queue, somewhere to put these messages into. The workers, the little people that actually are signing up to a job queue and waiting for jobs and doing stuff that you require, and beer, because you always need beer. So you could basically build up all this with any sort of messaging queue, RabbitMQ, ActiveMQ, even Redis publish and subscribe, ZeroMQ. Yes, you could do this with MySQL, which is weird and insane, and I've done it and it was wrong. So you may see a robot plugin somewhere on the Cake plugin repository, which was totally insane. But back when I did it, it was a requirement that it had to be run on MySQL. I don't know why. It was a client that required that. So we did it that way. There's a project called Cake Rescue. I actually didn't know about this until I started preparing the presentation and they contacted me. They use Redis mainly for this. So I'm not going to cover them. I'm going to cover Gearman. But if you are interested in a little bit less power into the way that you can control the processes that you spawn, then Cake Risk could be a good option for you. It's built on Cake 2.0. an app. Yeah, that's the GitHub repository if you're looking for it. So the idea behind Gearman is a little bit more than, it's taking the message queue processing system and taking it a bit more. Gearman is actually a, how do you call this in English? Anagram? An anagram for manager. So yeah, it's a Harry Potter moment. I didn't even know about this, I just found out. So yeah, to break it down, Gearman provides a client API where you can start posting tasks into. You need to send an email, you post a task using the API to dispatch a task. You have the job server, which actually is the Gearman daemon, the server that is waiting or listening for messages to come in. It's nothing more than a messaging queue. Then you have the worker API, to register to the server and say, I'm ready to do some work. And whenever work comes in, I actually do the work. It's multi-language, which means you can create the workers on PHP and spawn the task or dispatch the task from Python or whatever, any sort of combination that you can possibly think of is pretty much supported. It's multi-platform, sort of. I guess you can run it on Windows if you're brave enough to get into CIG, Win, or whatever, that little thingy. Synchronous execution is actually is one of the examples why this is far more than a simple messaging queue to process jobs, because it provides the capacity for a client launching a job and waiting for the actual result in the same process, which is insane. Job status callbacks is actually adding another layer of information between the worker and the server and the client dispatching the worker, where you can say, I don't only want to know when it's done, I actually want to get regular feedback while the worker is processing. We're going to see examples about all these procedures. It's super scalable because you can build up several Gearman servers and attach multiple workers to the same server. You don't even have to think about just one worker per machine, because if you think about multi-processing systems and you use one process attached to each CPU, if you have an 8-core CPU in your server, you could have 8 workers on the same server, just waiting for tasks. How does it look? Let's get a little bit into the detail. When you want to dispatch something, you're saying, I'm going to dispatch a task. The first thing that you want to do is understand if you actually need the result of the task in the same process, or if you're comfortable just dispatching the task and letting it be. In our email example, we would be more interested in that. Just dispatch the email send request and let the worker handle. It's very simple. You connect to the server. The add server line in your development environment is not even required. By default, it's going to be on the local host. You trigger the background call, do background. You have the possibility to also use priorities in the task. So there are different flavors of the do background tasks, such as do background high, do background normal, do background low. So you can prioritize the tasks that you spawn. And you say what task I'm interested in spawning and which parameters. The parameters is obviously one single string. So if you need a little bit more, more flexibility in your data types for the arguments that a worker will receive, you will have to think a little bit of JSON or whatever, which we are going to do. On the worker side, it's actually as simple as the client side. You only create the instance of the Gearman worker class. This is a PCL extension. This is based on the PCL extension. Gearman also provides a pure PHP implementation of the library. I would recommend the PECL extension for obvious reasons, performance. And you sign up or you register a worker for the task hello with the implementation right there. Whatever you're doing there is up to you. If you return a value because you need to or whatever, it's fine. If you don't, just consider it that if you don't return a value, the synchronous call of the task wouldn't make much sense because you would never return anything. But most of your tasks would never be synchronous. They would be totally asynchronous. And once you register the function that the worker does, this PHP file worker does, you just say, okay, I'm going to start waiting for jobs. If we have time, I'm going to show you another way to actually do this. There is non-blocking mode, because obviously right here, once you trigger the worker work call, it it blocks the whole process until you get something to do. Then it does it, and then you just sleep there for like 500 milliseconds because that's like good practice. Once you've created your client and your worker, the first thing that you want to do is actually try it out. This is a very simple way to debug Gearman, where you telnet into a port when you launch Gearman by the command line using the debug mode. It opens up a port 4730, where you can just issue like very simple, stupid commands to check how it's doing and whatever. If you use the status message, it's going to give you the register functions, number of workers and items in queue, and that sort of thing. This probably is going to be useful the first day that you play with Gearman, and then you will never use it again, because it's just debugging. And the way it works, the example that we built, you would just launch the worker, wait for a worker to get some jobs. This is the actual worker work class call where it's blocking the whole process, and the client just triggers the tags. Since we did a background task, the value returned by the do background operation is a handle, a job handle that we're going to see why we would need job handles and what they're good for. But most of the times you don't even take that into consideration. You just pawn the task and that's it. And when the worker receives the task request, it actually does what we said it should do on the anonymous function. So what happens if you actually want to do something with what happens if you want to do something that the worker should give back to the server, to the client actually requesting the task? It's pretty much exactly the same code as before, only that we change the method name. We say do normal. Again, 3 priorities, normal, high, and low. So when you don't use the background word in the method, it means that you want a synchronous operation, that you want to spawn the task and get the result right back. And the result that gets sent back is actually the result of our worker. So in here, since we are returning a hello who, whenever I call from the client, I launch the worker and I call it from the client, I get hello Mariano. Yeah, sure, interrupt me whenever you have questions, sorry about it.
And it also just returns strings?
Just strings. But again, if you use JSON, we are actually going, at the very end of the presentation, we're going to see how to use this in Cake. Very simple way to pass things back and forth in Cake. Yeah?
Why would you want to have a return value?
Well, it could be a lot of things, and we're going to cover why synchronous operations are actually useful, and even more, why you would want synchronous operations that report data back while they're working. We're going to cover that, but...
And the parameter, you just enter name, can only be string type or JSON?
Yes, always strings. Again, because it's totally multi-platform and multi-language, so the only basic data type that every single language can talk is strings. So that's why you will add another layer such as JSON or whatever you want to serialize. If you want to use PHP serialize function because you're biting the head or whatever, you can use that. It will work as well. But the problem, when you see the operation or the way that we are implementing the worker, you may realize that we may have a problem. Because what happens if the worker, for some reason, throws an exception? That's something that is really bad. What happens with the worker? It dies. So there's nobody else listening for jobs, and my whole system breaks down, and I'm not sending out emails, and I get fired the next day. So the way to avoid that is to think of something that could handle the processes for me. Make sure that I have a minimum number of workers working, and whenever a worker dies, it gets brought back up and everything. Supervisor is for this type of procedures or for anything that has to do with a daemon is the way to go. I know this because there are different implementations, one of them including mine, but for another framework, Lithium, that does a parallel job to Supervisor implementing the actual children processes. That's okay. I don't know why I did it, probably because I was masochist or something, but the best way to do it is just let Supervisor handle the task, and let Supervisor throw the binary or launch the binaries, which are your PHP, up and make sure that they stay up. This is a configuration file for Supervisor. It would probably be the configuration file that you will use on your workers. You will mostly don't require any sort of changes. What you can see here, well, this is very basic. I'm not going to explain it because it's like very basic supervisor. But the interesting part here is the command, which is issuing a PHP call on my worker, and then making sure that I put a process name or something that I can identify the different workers, like worker 1, worker 2, and worker 3, and making sure that each of these workers have a different log file that I can check later on or whatever. And the interesting part here comes there. Number of process. Obviously, it would make sense to not put more processes than you have CPUs on your server. Auto start and auto restart. Auto start, if it's not already started, just launch it up, and auto restart, if the worker dies, just launch it up again. So with this, you're guaranteed to have always a worker listening, unless the worker has like a fatal error on the very first line, and then you will have like an endless loop or something, which is weird because I didn't see any way for Supervisor to say, keep trying up to this point. But you will probably use Monit or another tool such as that to make sure that you can handle such weird situations. So yeah, I launched Supervisor with the configuration file that I created, and immediately this little part enables a local server where I can check the status of my different worker processes. This comes from the names that we defined on the log file, on the configuration file. So whenever I see, I can have this and check regularly if the workers are working, clear the log, check the last few number of lines from the log and whatever. And then you can do this all from the command line. So if I do that, whenever I launch Supervisor, I already know that there are workers working. So I can immediately call, like I did before, call my client operation that dispatches the task. Okay, so I skipped. Okay, yeah. So this is going back to your question. Okay, what would I need? Not only the result back, but when I said that you could also actually use some sort of interaction between the client and the worker. Right here, I'm doing something like a made-up task where I say, okay, I want to, convert 3 files, 3 images files. And what will happen if I have different workers? How would Gearman handle that? It will probably, when I launch the task, it will probably separate this between the different workers. When I launch more and more tasks, like if I immediately launch 3 tasks to do for Gearman, it will separate them across the different workers, and I will not have a guarantee order on which worker takes care of which action, and it will be pretty much distributed. So statuses become really important to know if I really need to understand what sort of in what part of the processes I'm getting stuck, or if it's taking time, or if it's in the processing file, what part of the processing is doing is actually opening the file, report me when it's 30% done or whatever. Obviously, you will have to implement that from the worker side, so you have to have some sort of way to bring that back. So you use job statuses for that. The way to say, okay, remember the handle that we got when we launched the normal background? That's the way for you to use Gearman and say, okay, I want to know which part of the process is being done. Right here, I'm again implementing another worker. It's a little bit more complicated than the other one. First thing that we see here is, again, JSON, since I have strings, and my task sends as a parameter an array. I want to somehow translate that back to PHP array, so I use JSON. And what I'm doing on this worker is going through the 3 different files. Instead of spawning them on 3 different tasks, I want to do it all at once. So I go through the files and I send a status. This is again a Gearman API call, where whenever you get whenever you're working, you always get the job handle right here. The job handle as part of the call that Gearman does when you're working. So you can use this job handle to send status messages. The status message is always a number, 2 numbers actually, a numerator and a denominator. So you can build a percentage or whatever system with that. So in this case, I'm using that to say, okay, which part or which number of files I already processed. The rest of the worker is exactly the same. Again, I'm blocking until I get something to do. So how do I use it from the client? Again, spawn do background, just as before, but the difference is, where is it? Oh, yeah, here. JSON encode, I'm sending the array, and then I'm getting from the job status call, here. From the job status calls, I'm getting the number of process and the number of total and queued and running tasks that I have. Queued and running, you can check this on Gearman documentation, is a way to know if the job is completely done, is completely finished. So if it's not queued, it means that I'm done, that there's nothing for the job to report. If it's not queued, it means that we are still processing the job. So I can use the processed and total number, which are the number of denominator, and I keep a track of how what number of processes or what number of numerators came from the client. So I can keep track of process 1 file, 2 files, 3 files. Okay. Parallel tasks. Parallel tasks was actually when I started talking about this process where I sent 3 files in one worker call. I could actually, if the process or whatever the implementation allows me to, I could separate this into 3 different worker tasks. And that's where things get interesting. Parallel tasks are not as unusual as one thinks. Because you have, for example, when someone signs up to my site, I could not only need to send out an email as part of their registration, but also increment a counter, for example, of users that I'm caching, pre-create a profile page, do a lot of things that, again, don't require user interaction, but I need to do, and I want to make sure that nothing in that process that can be done independently is done on the same process. So I can separate in 3 different tasks. So I'm thinking, okay, then that means that I can do and start spawning a lot of tasks. But what happens if I need the whole report or make sure that I get a report when everything is done? So this means that I'm not only separating things because I know that I can do them independently, but because I may have different workers, different machines that are more suitable for one type of work than another. I could have a machine that, I don't know, has more processing power to handle all the video conversions or whatever I'm doing with a worker, and I could have a very simple machine just to send out emails. When you're thinking about like a very small website, that doesn't make any sense, but when you're thinking like millions and millions of users, you start thinking a lot about resource optimization. So parallel tasks are a great way to handle that, because I could have different Gearman servers on different machines and just throw 5 different tasks, and there's a worker on one machine that is particularly designed for video conversion. And at the same time, I'm launching another task to do the email sending that is going for a much lesser important server, but at the same time, I want to make sure that I get a report when everything is done. With this sort of thinking of parallel tasks, you can do stuff a little bit more interesting for map and reduce tasks. You could have a huge, I don't know, log file that you need processing for some reason, but you want to make sure that you don't do it all at once, so you divide into different worker tasks that handle different parts of the log file, and then you have something that takes care of everything and reduces that to an actual output. And you could have one Gearman server for the whole mapping process and one Gearman server for the whole reducing process. And you can achieve some crazy stuff like that. You can even prioritize the tasks that you send on different places. Again, using the normal, high, low priorities. It's parallel, so you're doing everything at the same time, so it's obviously faster. I don't even need to clarify that. So how do they look? They're not actually. If you go through the different slides, I'm going to upload them later. You're going to see that it's very simple API. There's no real complication. But from the client, we said that we want to launch different tasks, but we want to make sure that we get a report back when everything is done. So the very first thing that I do is say, okay, I want to make sure that I get a status callback. A status callback, so I can get a report back of what part of the process I'm in, very similar to what we did before, only that I'm just taking care of showing the numerator and denominator. Again, these 2 data is data that the worker sends to me. a complete callback. So when everything is ready, I get a report, again, a function executed where I said, this is done, this whole batch of tasks is done. And then I just add 2 different process calls. And on this particular example, I just reuse the same worker that we had before, sending 2 different batches of files. So I want to process these 3 files, and then I want to process these 2 files, and then I say, okay, go ahead and run this whole thing. So since I register these two methods, Gearman is going to obviously wait for this whole thing to be completed and then execute the callbacks as specified. So if I run it from the command line, I start getting reports from the status callbacks saying process 1 of 3, 2 of 3, 3 of 3. And if you notice these, there are 2 different batches that we had, 3 files, 2 files. So I get process 1 of 2, 2 of 2. This is the second batch, and this is the first batch. There's no guarantee in the order that it gets executed. That's why it's totally parallel. And then I get reported that both tasks got finished. This is a idea that Gearman has. There's a way to keep track of the status of tasks in different engines that we're not going to cover because it's a whole thing by itself, but you can keep track of that. And if I look at the log files that Supervisor created based on my documentation, I see that each of the workers were handling a different batch of the files. So this is the second worker that reported 1 of 3, and this is the first worker that reported 1 of 2. I'm going like really fast with these slides, so if you have any question, please interrupt me. So what about CakePHP? How do we, Kit is always a guarantee winner on any presentation. Okay, so how do you use this on CakePHP? If you realize that we never moved away from like basic PHP, it's not going to be that complicated. The only thing that you have to ask yourself is, what do my workers look like or will look like? So which parts of my application I actually can, spawn down, put as workers, and which parts of the applications are actually going to launch the workers. Very simple example. What I'm doing here is just creating a jobs controller. Very stupid, nothing practical here. But I'm doing the same stuff that I was doing before. The only difference, if you start analyzing a little bit the parameters that I'm sending, is I'm taking the job request a little bit extra or further more interesting by saying what action I want to go and with which parameters. So this action actually could be a static method in every class or whatever class that I want. So you could have, in this case, I'm actually using the same class, but you could have like a class to handle the email sending, a class to handle the file processing or whatever. As long as the worker implementation can know what to call from the parameter you send, then it's okay, it's fine, and you can do it. So in this example, I just did a very general call where I said, there is a worker that I give the fully qualified method name and a set of parameters, and it's going to execute it, no matter where it comes from. So this is actually not even CakePHP. It could be done on any framework, any sort of library that you have. And the implementation is very simple, just doing a hello on, like our previous example, hello on the variable. So the worker implementation has a little bit more logic. It has to have a way for me to decode the parameters that are being sent to me, JSON decode it, and then do the actual call. So right here, what I'm doing is I'm registering a generic method called run. When we launch the worker, we just call run. This is my generic entrance method. So the implementation of run is an actual method of this class called the worker shell, because I'm going to launch my workers from a CakePHP shell. So this method has somehow to know the way to do the work. This is the worker shell, a start method. So whenever I call it from CakePHP, I just put the start parameter, and it's going to start the worker by registering to Gearman, registering the function, which is another method in this class. Well, doing a little bit verbosity there, just saying done and register and whatever. I'm waiting for jobs. It's not very different from before. It's just a little bit more verbose because of the output that I'm using there. So the run method, the method that is being registered for the run operation, is where the magic happens, which is not that magic anyhow. So I'm taking the whole string, the input parameter for the worker, decoding it through JSON, and using the parameters that are being decoded, where I know there has to be an action parameter saying what I should call, and then doing the actual call right here. If you see this part, it's just very dumb example of if I'm making controllers static classes being called, I need some sort of way to know to load these classes. Because if I'm doing a static operation on a class that at this point in the shell it wasn't included, obviously I will have an error. So I added some dumb logic to say if someone is asking for a controller static method, just load the controller through app uses and then just call the method. And whatever is results from the method, I'm returning. Again, because I don't know if the client would want a background operation or a synchronous operation. I don't have this. I'm not going to put this on GitHub because it's like very dumb example, which is not even practical. But I'm going to post the slides so you can take examples from there. But with this, you have like a worker shell that you launch and you register your worker to. A little bit of lessons learned on my own experience when dealing with Gearman. Processes obviously stay alive, and they stay alive listening for jobs. But if you think about a long-running process, you may have all sorts of problems. Even if PHP 5.3, 5.4 actually really improved the garbage collector, at one point in time, it's going to die on you. I know a friend of mine, a programmer, who did a whole, I don't know, he has a website that deals with a lot of social networking and millions and millions and millions of users. So they have like Gearman workers being launched, like 100 Gearman workers in the same process just for doing all sorts of crap. And in their case, the workers are so heavy that they die like, I don't know, 30 or 40 times a week. So Supervisor, again, is a lifesaver for this occasion. So your workers are going to die. Just expect that. Check for DB reconnection. Since we have a long-running process and your worker at some point connected to the database, which would normally be the case if you're using CakePHP, at one point it's going to time out, unless you use persistent connection. So make sure that you don't assume that things work the same way that they work when you're accessing through the web browser. Just make sure that you check everything can go down and will go down. Even if you use some sort of SMTP or whatever socket connection, again, they're going to die, so make sure that you are able to reconnect and make sure that your worker can be done. Workers can be killed, so that's very basic. With Supervisor, I don't even care, but you just have to know that they will be killed. Be mindful of memory usage. This comes, actually, if you've noticed, whenever, well, I'm not gonna go back, it's like 100 slides before, but if you notice, whenever I did the while work call, I always put a you sleep. It's like common practice for me to put a you sleep on any loop whatsoever. 500 milliseconds on that case, maybe a lot, you could actually use less, but those milliseconds that you put are precious for garbage collection. So if you have loops and whatever, just make sure that you sleep. Your servers are going to be very, very grateful. Account for process switches. Again, same concept. If you do the you sleep, you're not only accounting for garbage collection, but process switches, which is really important if you run more than one worker on the same machine, which normally would be the case. You want to make sure that you utilize all your CPUs. Well, yeah, we do have time for a bonus track and a lot of time for questions. So, bonus track. This is actually going to be a challenge for everyone. And if someone figures it out, I'm not only buying beers, I'm buying you, I don't know, a meal. There's a way using the PECO extension to use non-blocking mode in Gearman. But it's been broken every single time, and there's like an endless bug report on PHP. I have the number if you want it. that they keep trying to close it, but they can't close it, they can't close it, and they can't close it. It happens on certain PHP versions, but on most operating systems. So if you're lucky enough that your server can handle this, then you're very lucky, because it's much better to use non-blocking to handle these sort of loops to get the task than actually blocking the whole process. Why? Because we have time for process switches. If I'm hanging the whole process on PHP here, it's much different than if I have time for the process to keep going back and making sure to see if they have jobs or not. So try it, and if you're lucky that you cannot replicate the bug that I'm saying, go into the PHP bug, because most of the people are replicating the issue. But the two members of the PHP core are sure that it's no problem. So, but it's a problem. So anyway. Questions or anything? Comments on the speed of this talk? No? Okay, cool. Thank you. We have time for anything. Beers.
Mariano, I have a question. Are you using this on Workana?
Yeah, of course. Yeah.
And how many processes do you have on average?
Actually, we have like 10 workers.
10 workers?
Yeah, and 10 workers on 10 machine, which is 4 processes, so 40. But they can handle anything. We were like over the edge, expecting any peak of traffic to be handled. We had situations where the main process that was listening, not supervisor, before supervisor, the main process that was taking care of the workers to make sure they stay alive died, and then slowly each worker died, and then we went into a situation where we had a lot of tasks pending and whatever. But yeah, so that's the main tip that I can give, is always make sure that you check your processes. But yeah, we use it, and in the particular case, it's actually a comment that I forgot to make. You know, when people talk about application performance, everyone says caching. Caching is fine, but the actual performance increase is going to come from right architecture on your system. And weirdly enough, most people don't do the right architecture, even when the right architecture is very easy to achieve. The example of the email sending, writing the request, is an example that you see on every single application. And it's a stupid mistake, because instead of worrying yourself with gaining 10 milliseconds just by caching a database operation, why don't you take care of a possible 2-second delay on an email sending? You should be.
The SMTP is done. We've been set for like 5 minutes.
Well, it's insane, and most people make that mistake. And you don't require a whole 5-server architecture to do this thing. You could actually do it on the same server. You can have the same Gearman on the same server and make sure that you trigger everything. In the case of Workana, our application, we're actually overboard. Everything that can be done non-interactive is non-interactive. So workers are constantly working. But that's why when you go to a website, it feels completely snappy, and everything is running.
Also on Lighthouse, they also use workers. If you bulk edit tickets, and you just move 5 tickets to another milestone, that puts it in a queue. It doesn't do it straight away.
I don't understand now.
On Lighthouse, the tickets.
Oh, Lighthouse. Oh, okay.
Everything that you do there,
It's separated. Yeah. Yeah, because it makes sense. Why would the user wait for anything except what they actually need to be waiting for? Yeah. Or even if you have stuff that the user has to wait for, again, the concept of having a separate machine that can have more processing power to handle a particular set of tasks can increase your application by doing the synchronous code that we were seeing. So video processing, obviously, you don't want the user to wait for that. You want some sort of, Ajax/WebSockets communication back and forth to make sure that you see the progress. But there might be examples where you want to provide something right in the user request, and it's something that could take time, so just spawn it to another server. And when you start doing this and separating everything into different workers, you end up realizing that your web server machine can actually be really simple and not that expensive. Like a large instance on Amazon will handle a lot of users, even more if you move from Apache to Nginx. But actually, Apache, the latest version, is actually quite fast. But so, yeah, the right architecture is right there. It's weird that nobody is doing it, or most people are not doing it. Please get on with it. And you are going to realize that you don't have to you can actually then spend time in the little performance improvements because your whole application, the main performance bottlenecks are handled by you. And implementation in Cake or any framework is super easy. There's no reason why not to do it. Another thing that may be interesting is the handling sort of not log in the sense of log files, but keeping track of what jobs got done, which parameters, but mainly which jobs got errored with which parameters, so you can try to respawn them or relaunch them and make sure that you can recover. Gearman has capacity to use a central storing system. Could be MySQL, could be other things. I personally use Redis for that. On my workers, I always create a Redis key with the whole parameter set. And I delete them when I know the job is done, because I'm fine, it's okay. But if the job error or whatever, it stays right there, and I know that it got into a situation where something needs to be done, and I can double check. So that also may be very useful to make sure that whenever the job errors out, store the information, the parameters, and since the workers are actually independent entities with only the parameters, you're going to be able to replicate whatever happened. So if you store the errors on Redis or MySQL or whatever, you're going to be able to recover error tasks, which is something that would never be possible if you're doing all this stuff as part of the client request. If the email broke when the client was waiting for it, you're fucked. You lost the user and you lost the email. This way, at the most, the user could complain, I didn't get the email, and you can say, oh, okay, this task didn't get done and whatever. Ourselves, we even have, we took it a little further, and whenever there's an error, we get a process that actually schedules it back on track. And we also have, using Monit, a ping operation, a ping worker, where it's a worker just listening for pings, not the Gearman ping, which is useful to know if the Gearman server is up, but mainly a ping worker to make sure that whenever that there's always a worker listening. Since we use a central worker system, where same concept as we see here, but a little bit more complicated, I know that if there's a worker responding to a ping request from a client, then I know that the workers are up. So we have a Monit operation triggering a shell script that's because Monit only cannot deal with parameters, so you have to build a shell script that every 2 cycles or 3 cycles in Monit triggers a ping operation. And if the ping doesn't respond, then I know something is wrong. And there are no workers, supervisor went dead, everything went dead, so probably when that happens, the whole server is down. So, but yeah, that's also another tip. Just implement a ping operation on the worker so you can continuously check. If you want to know a little bit more about Monit, which is also going to save your life, check the slides that I posted yesterday on my other talk, random tips or whatever it was called. There I give a little bit of examples on Monit configuration files and stuff. But yeah. Okay, it's not about 10 minutes. I can keep talking. Huh?
Yeah, there's a lot of room in schedule.
Yeah. Well, it was the last talk, right? Before the... So.
But
Yeah, but that's after a break, I think.
yeah, but the he starts at 6:30, I think.
Oh, I don't know.
What's all going on with the schedule? I think we... yeah, well, I think something went wrong with the schedule.
What?
Don't toss him around. Yeah.
Oh, yeah, you're right. Afternoon tea and Pechacuchas. Well, the Pechacuchas, no, it's same as last year. Pechacucha submissions get done during the afternoon tea.
Yeah, there was a half an hour gap and there are duplicates, so... This was supposed to be...
Bunch of amateurs.
30-minute slot.
Oh, yeah, so there's like a whole hour.
So either they're on a desk during the day.
Have you seen the stuff runtime?
The what?
With DJ Job? It's like a clone of some Ruby like job thing. But it's not like all fancy and stuff. But it's just like 20 lines of PHP that process forking and stuff.
Well, that's what I did on, if you go to github.com/Mariano/ally3 li3 underscore Gearman.
Yeah.
That's my Gearman plugin for Lithium, and it has both the capacity to run as a stupid worker, which would be the way to use on Supervisor, or if you don't want to use Supervisor, it creates the number of processes that you want through child, communicates with the child through signals and stuff, and it's insane to do it that way, but I didn't.
But it shows that it's easy to do that, like even if you're on shared hosting or something.
Yeah, you can do it anywhere.
There's no like you have to have special software and things like that.
No, yeah, you can do it anywhere. And again, it's weird that even on the K core, the content cache behavior, and I'm partly responsible because when I was back in the K core, I touched that. I never thought it was a bad idea. It's really bad idea. You're doing a whole count operation. What happens if you have, I don't know, 1 billion records? It's insane. Like every sign up, fuck. Next page, fuck.
And some people like have the same model, like related on aliases to do different counter caches.
Oh yeah, and then you can have I've seen that. I've seen you could have that's true. You could have like 7 or 8 bindings, each one with a counter cache operation, and if each table has million records, then it can be the whole conference. Yeah, it's insane. Oh well, and if you don't want to use Gearman, if you don't want the capacity to do the whole, synchronous calls, parallel calls, and whatever, which you eventually will, but if you don't want to complicate yourself, again, the cake rescue thing that these guys did could be the answer for you, because the concept is the same. It's just that you don't have this power. That's why Gearman is not considered. When people say you can implement job queues with Redis and stuff, that's true, but you don't have all this power behind you. And that's why Gearman is being used like throughout everywhere.
Did you make in your cake like behaviors and components and everything for sending out jobs?
On Lithium, you mean?
Didn't.
Sorry. No, what I have is, actually I have a central class that takes care of this whole JSON serialization, the Redis creation, where I keep track of the statuses and all that stuff is done on a central class. So I only use job dot or whatever it's called, run, and then it just, but very similar to here. I just told which class I want to, which method, fully qualified method, with which parameters, and then I forget about it. There might be some drawbacks with using JSON, but since you're going to be implementing the worker yourself, like stuff such as date times, you have to figure out your own personal format, because if you're serializing a datetime into JSON, there is no format, because JSON is just objects with attributes and values, and there is no datetime whatever. So that's important, because most of the times if you have a multi-zone application, you have to take care of passing the zone and whatever, and that sort of thing. But you could use PHP serialize and it would be fine.
It's not like a good idea to serialize class instances.
No, never. Yeah.
It gets like hands on Windows.
Yeah, it has. We always keep it like very basic data types. Like anything else, actually, you don't need anything else. One mistake that even people that use this methodology to send out emails, they make, and I'm talking, I think even Twitter does this. Did you never get from a website an email as a result of a notification that someone sends you a message and it comes in the language that person has, like in Portuguese because they were Brazilian? That's because they stupidly made 2 mistakes. First, come on, I mean, you should bring in my language, but they make the mistake of rendering the email as part of the task that's being launched. Again, why are you using client time to render the email? You could just send the very basic parameters that you need for the template of the email, like from to what, and rendering on the other side. And on the other side, you can take care of the user language and everything, so it comes properly. And again, you're saving time. And so, if more people would take into account those things, applications would be much faster and much nicer to use. But they still think that the way to go is caching a very simple SQL. That's not the only way to go at all. So yeah.
go, man.
Okay.
Freezing.
Yes. What is up with the air conditioning in this place?